So the title of this talk is JMS.next, JMS 2.0 and beyond. My name is Reza Rahman. If you don't know who I am, I'm an evangelist with Oracle Corporation. I primarily focus on Java EE. My email address and Twitter handle is up there. If you want to get in touch with me later, which I do hope you do, one of the reasons I'm here at these conferences is to connect with you at an individual level, something that I can't do behind a screencast or a blog and the like. So please do take advantage of that. I sort of allude to here, I will be talking principally about JMS 2.0. JMS 2.0 was released along with Java E7 about a year ago. However, since I do have the bandwidth in this particular case, I will also be covering a bit about what we are thinking of as to JMS 2.1, which is going to be the next major revision for the JMS platform slated for Java E8 around the end of 2016. Okay, so here's I guess something else that you should know is that before I joined Oracle about a little over 2 years ago. Before I joined that, I was actually an active expert group member in JMS 2.0. So my goal actually, when we get to talking about JMS 2.0 and JMS 2.1, I sort of weave a story from my perspective, if you will, in terms of what we did in the EG and why we did it and sort of what the progression was. So JMS, I think we all know here. If you didn't know about JMS, you wouldn't be in this room. It's a pretty small, simple API. It was one of the original APIs in J2EE. It's one of the older parts of the platform. Essentially, it's a Java API for message-oriented middleware. Okay, it's highly successful principally because when I talk to server-side Java developers, almost all of them know about JMS or have used JMS. I think a very high percentage, in my view, at least 60 to 70% have used JMS, and JMS is pervasive. If you look at our server-side Java ecosystem, JMS is pretty much everywhere. Unfortunately, it is also an API that hasn't gone through a significant update for a very, very long time. Okay, so the last time JMS was updated was in 2002 with JMS 2.1. That was still the J2E era when we still called sort of the standard server-side Java J2E as opposed to what we call it today, which is Java EE or something a bit more along the lines of not calling it J2SE or J2EE, but rather it's just the different variations of the Java platform. JMS 2 was basically released, was started around 2020, rather ended around the end of 2014. It's included in Java E7. So far, as we've done this talk and talked to the community, it's been relatively well received, and for good reasons, I hope, as you'll see during the talk. We have, as I said, already started work on JMS 2.1. So that expert group is already up and running. Not a lot of activity on that expert group yet, but hopefully that will spin up, let's say, in the next month or so. So this is a good time for you to get involved in JMS 2.1, if you so wish, the JMS API, just as I chose to do many years ago with the JMS 2.0 effort. Okay, so here is my sort of plan for the next 75 minutes or so for your time investment. These are basically the features of JMS 2.0. The principal feature is API modernization. So as I mentioned, JMS 1.1, well, that was a lifetime ago. So during that time, since JMS 1.1 and today, we've learned a lot of lessons in the industry in terms of API design. Okay, so if you think back to when the era of JMS 1.2 and JMS 2.1.1 was, Java itself was still in its infancy. And today, of course, Java is one of the most pervasive programming languages in the world, if not the most pervasive programming language in the world. So as a result, we have a lot to learn from from the broader ecosystem as to how to design APIs, and also lessons that we've learned in terms of advancing API design as well. So we wanted to take this opportunity to really revamp and make an optimal API out of JMS 2.0, and that's where we spent a vast majority of our effort. There are some new features, okay, that are included in JMS 2.0, not a lot of them, and I'll talk to you a bit about why that is, and maybe you'll find that surprising or not. There was a bit of alignment with Java EE and a bit of alignment with EJB3 that was necessary. Again, that was a byproduct of the fact that really this API hadn't been updated for such a long time, and JMS is one of those funny Java APIs that are included in Java EE that has two flavors. You can use it in Java SE or you can use it in Java EE. And sort of JMS 2.0 was a perfect storm in terms of taking advantage of making sure that JMS is as easy to use as possible in a Java EE environment rather than a Java SE environment. Okay, so we did a bit of that. And there are actually a boatload of other things like minor corrections and clarifications. Most of them you wouldn't even notice because a lot of them are actually geared towards major API vendors. So the question you should ask yourself is, how did we arrive at these? Okay, and the answer is the process was quite transparent and quite democratic. So Nigel Deacon, who was the spec lead for JMS 2.0 and also going to be the spec lead for JMS 2.1, convened the EG, including folks like myself, and basically he said, hey, you guys tell me what your priorities are for JMS 2.0, and we all compiled our own lists, prioritized lists, including things like revamping the API, including things like adding new features, including going in new directions. And basically what we did was we created a master list, okay, of all what we all were saying, and this includes people like me that were just independent developers that were involved in the spec, as well as folks like vendors, and that is how we arrived at our backlog for JMS 2.1. And surprisingly, the big, I guess not unsurprisingly, maybe by far the highest priority item was API modernization, various ideas on how to modernize the JMS API. Surprisingly, not a lot of us talked about new features. Okay, so and the reason, I guess, to a degree, is because we are JMS users, right? We're used to a small API, so we didn't want to add a lot of feature bloat. We wanted to keep features relatively reasonable and relatively clear. However, if you have JMS features in mind, okay, new features in mind, you should voice those now, and you'll see what we have in mind for JMS 2.1. If you see something missing, this is a great time for you to provide those particular ideas, inject those ideas into the spec thinking as well. Okay, so I'll start in the most obvious place, modernizing the API. This is the old JMS 1.1 API. I won't go through this API because I hope that a majority of you have seen this API at some point in life or other, or you today perhaps are unfortunate enough to use this API as is. Okay, let's talk a bit about this API as to what its problems are. How many of you understand empirical versus rather than functional programming? Distinction between empirical and functional? Okay. Functional programming is when you tell the machine what you want done. Okay, what is your end goal? And imperative style programming is when you tell the machine how to do that particular thing that you want accomplished. Okay. When you look at this bit of code, in fact, the functional core of this code is this one line in red. Okay, so what you are doing there is that you are sending a text message to a JMS destination. Okay, that is the one-liner. The rest of this API, okay, is imperative code. All right, so it's mechanics of APIs to get to this functional core. You're telling the machine, this is how you go about doing what I ultimately need you to do. Okay, so clearly there is a big red sign. Okay, so this is a terrible ratio of empirical versus functional programming. The functional core here is extremely small. Okay, so before you understand JMS 2.0, it is important to understand how did we arrive here? Why is this API this way? Okay, and believe it or not, the API being this way, the core part of the problem is actually not a problem if you look at the time frame when this API was developed. In fact, if this API wasn't designed this way, there would have been a high chance of failure. If we tried to accomplish this from day one in JMS, likely we wouldn't be talking about JMS today. Okay, and I'll explain why that is. So first and foremost, what are the problems here? The most obvious problems are these intermediate objects that we are creating. Okay, so in order to get to the functional core, we are having to deal with a connection factory, a connection, a session, a message producer, and a text message. Okay, quite a few artifacts there. So it's important to understand, first and foremost, why do these artifacts even exist? Okay, so now let's go back to the time machine and think about the API designers for JMS 1.0, because these are JMS 1.0 APIs. Okay, so you are tasked with the job to create a Java API for message-oriented middleware. Okay, message-oriented middleware thus far has existed in only one major system called IBM MQ series. Okay, it has no other precedence whatsoever. So there are some, these are the early 90s or late 90s, and there are some other message-oriented middleware products like Swift MQ or Fiorano. Okay, that use their proprietary APIs, but the biggest precedent is essentially WebSphere MQ. Now, your job is to create a standard API that WebSphere MQ and all of these other emerging players, including things like WebLogic at the time, are going to need to implement. Okay, you have actually very little idea of how this message-oriented middleware is going to be used in the real life as the internet expands and as Java expands. So your smartest bet, okay, to create a successful API in this case, is to build an API that is as flexible as possible, can do as many things, meet as many requirements as it possibly can, so that this API can evolve over time, can handle those use cases over time, because you don't know what your use cases are. The simplest design technique to do that is to create a very granular API. Okay, so have essentially command objects for every single possible thing that you can do, and allow for mixing and matching of these command objects in arbitrary ways. All right, and that is how you essentially arrive at an API that has a lot of intermediate objects. That's the fundamental reason for it. So that is why today you can do all these nutty things with message-oriented middleware, is because of the flexibility of this API. So you can do things like just send one JMS message, just receive one JMS message, send 1,000 JMS messages, send and receive messages in the middle in the same session. Okay, open up multiple connections, start and stop connections in the middle. Basically anything that you can imagine you can do with the JMS API because of this API flexibility. All right. Now, the other thing you will notice here is the open and close phase. Okay, we are creating a connection factory and closing the connection factory. Why is this? Well, this is because you are dealing under the hood with a network resource, an IO resource, and every single IO resource will have an open on a close phase. Okay, so that is why the open and close paradigm here exists. The other artifact that is very obvious is this try catch. Okay, namely catching the JMS exception. Almost every single one of these APIs throws a JMS exception, and the JMS exception happens to be a checked exception. All right, and why is it a checked exception? Well, when this API was designed, pretty much every single Java API used checked exceptions by default. The thinking was, we're designing a new API for the web. We're designing a new API for the server side. This API needs to be very, very safe. Okay, so it's going to be hard to mess up with this API, unlike things like the way C or C++ handles errors. It's very easy to miss errors because they don't have this sort of strict regimen of handling exceptions. So the way we get away from that is we introduce checked exceptions, okay, so that there is a potential for error here and you must handle that potential case for error. Okay, so that is the design thinking behind it. But let's now deconstruct, okay, that design thinking and talk about why those design thinkings we can do better than those design thinkings today. All right. First and foremost is this API flexibility. Okay, so 12 years later, okay, we now have the luxury that we have an idea of how JMS is actually used in the real world. Okay, and we also have another API idea that we have learned called convention over configuration, meaning that you do not, it's not an either or whether you design a flexible API or not. You can attempt to design a system level API that makes the easiest common case as easy as possible while still allowing for the complex case. Okay, you can design an API like that, and hence you can take what you know of how JMS is used and apply those lessons here. Okay. Number two, and the other big one is we now do use runtime exceptions. If you look at an API, a modern API like JPA, okay, it uses runtime exceptions. So what is the design thinking there? Well, the design thinking there is it's too much to say everything should be a checked exception. Okay, because if you look at, for example, JMS, most of the cases when you are trying to catch JMS exception, these are either catastrophic failures. Okay, so something has failed massively in your infrastructure layer and there's not much you can do in the application layer to handle that other than simply throw up an error to say, hey, something is messed up, please go talk to the administrator. Or you've done something wrong programmatically, okay, and that will only happen in the initial development phases. It won't happen going forward. So in all reality, you can safely ignore these errors. Okay, you can apply runtime exceptions here rather than checked exceptions. Okay, so those are sort of the commentary that we can apply today in terms of looking at this API today. Remember, again, almost more than a decade old API. All right. So what is our goal of modernizing this API? Well, our obvious goal is to boil down to this, okay, to this functional core, to reduce the boilerplate down to exactly that functional core. And next I will tell you exactly how we accomplish that and what the design trade-offs are. Okay. Any questions on any of this so far? No? We're okay? All right. Let's move forward then. So in trying to accomplish this, what are our principles? What should be our thinking? Okay, so these were in fact our thinking. Number one thinking is maintain backwards compatibility. This is terribly important. Okay, we're Java developers. We believe in backwards compatibility. When you upgrade from JMS 1.1 to JMS 2.0, we cannot have a bunch of pervasive server-side Java code suddenly breaking. Okay, so whatever we do, we need to make sure that that does not occur. Every change that we make is a backward compatible change in all cases. Okay, and that is a very important and a tough constraint to deal with. All right, but and also simplify the existing API. Okay, within that, having that constraint of backwards compatibility, still try to simplify the existing API as much as possible. So try not to invent new APIs. Okay, work with what is there. However, if we must, okay, we can create new APIs, and these new APIs could be simple abstractions, okay, over the old APIs. The value of this is because it builds on top of the old APIs, it can coexist, okay, with the old APIs. So when you perform an upgrade, it's a zero effect upgrade. Okay, so you only can use the new abstractions if and when you need them. All right, and in fact that is what we wound up doing. All right, so we had no choice but to do so, and I'll explain to you why that is. So these new abstractions are JMS Context, JMS Producer, and JMS Consumer, and believe it or not, that is it. Okay, as a result of abstracting all of these APIs, there is now a small API of JMS is now even smaller. In fact, I'll contend that the only one API that you need to know in JMS today is just this, JMS Context. If you know this one object, you know JMS. Okay, so in fact, we have streamlined the JMS API even further in our effort to modernize it. Of course, we want to take advantage of all of the new Java and Java EE paradigms that are out there. So things like annotations, convention over configuration, I already talked about that, as well as things like injection and scoping, automatic scope management. Something that only existed at the JVM level at the time, namely garbage collection. Okay, now we have that even at the API level in terms of scope management. Okay, when does an object live or die is controlled by the runtime. Okay, so take advantage of all of these features to design a new API for JMS. Okay. I'll start with the relatively small change, okay, that we made to the existing APIs. Okay, so there's a little quirky little API in connection called create session. It takes two arguments, transacted and delivery mode. Interesting fact is that these are actually mutually exclusive parameters. Okay, what do I mean by that? So when transacted is equal to true, the delivery mode parameter is entirely ignored. Okay, it doesn't matter what you pass in there. The delivery mode parameter only takes effect is transacted is equal to true. Okay, so in fact, these should be just one parameter. All right, so it should be transacted, okay, and the other delivery options like dupes, okay, auto acknowledgement, and the like. All right, so that is what we did. We essentially introduced another a method in connection called create session, and that is a session mode. Okay, so one of the session mode is transacted, and the rest of them are the old or the other delivery modes. Okay, so that streamlines the API even further. Now, interestingly, in a Java EE environment, session mode is also ignored. Okay, so in a Java EE environment, the way it works is even if you specified a session mode, it won't take effect, because what's going to happen is if the session is created within an active transaction, it's automatically transacted. Okay, and if there is no active transaction, the session will actually be set to auto acknowledge, which is the only reliable possibility in a Java EE environment. Okay, so in fact, we can streamline this even more by creating a no op. Okay, no argument method here as well for creating the session, and this simply detects, basically says, you know, if you're in a Java EE environment, Java EE will take care of what the appropriate session is, depending on whether you're using this API in a transacted or a non-transacted environment, in transacted or non-transacted context. Okay. The other simple change that we were able to make is remember again that little spiel I told you about opening and closing IO resources. Well, guess what? There is a paradigm for that. Okay, it's called Java Lang AutoClosable. How many people are familiar with AutoClosable? It's was introduced in Java SE 6. Okay, a few. All right. So it's a simple one-liner, one-method interface. Okay, it just says AutoClosable.close. Okay, so anything that says close can implement this API very easily. Okay, and what is the value of that? Well, the value of that is that you can use it in a specific construct called try with resources. Okay, and we'll see how that works in just a second, since there are people in the room that are not quite familiar with AutoClosable. So what we did here is essentially make all of the existing JMS resources, okay, AutoClosable. So connection, session, message producer, message consumer, queue browser, all of them now implement AutoClosable. As a result, what you get is this. Okay, so this is another rendition of the code that I showed you before. So here we have the connection factory as before, the session creation as before, the message producer as before, the message as before, and the producer.send line, okay, the functional core as before. What is missing? No close, right? The close just vanished. Well, why, how did it vanish? It vanished because of the fact that we are using this try with resources construct. Okay, so when we do this, basically the JVM will detect the fact that, oh, these objects all are autoclosable, which means after I exit this try block, the JVM will automatically call the close methods for you. Okay, so you do not have to do that. So a bit removal, a bit of the empirical code already. Okay, so the container, the runtime is taking care of that for you. It's calling close for you, but not open. Yes, sir. It's triggered when the try, you exit the try block, okay, which is in this case would be this guy. That would not work. Yeah. Yeah, that would not work. It would have to be defined within in this fashion to work for try with the resources to work. Okay. By the way, I do have a bit of bandwidth, not a lot of bandwidth during this talk. So don't save your questions to the very last. Okay, if you have questions, please ask them. You know, we'll discuss them right as we go, as opposed to later on. There's no reason for that. Okay, so this is a first look at the new API. Okay, and I'll talk to you a bit later about why we arrived at this API. But for now, just bear with me. I'm just going to introduce it as is. All right. So the new API to do everything JMS, as I said, is JMS Context, right? So how this changes, and the JMS Context, by the way, is also autoclosable. It's a newer API. It is also autoclosable, so you can use it with the try with resources paradigm. Okay, and what you do here is you create the JMS context from the connection factory, and then you call this funny little line. All right. And you notice the difference already, right? All right, those are those intermediate objects. There's the message that we created and the producer.send, and okay, it's pretty close to the functional core already. Not quite. Okay, we've already reduced quite a bit of the empirical stuff. The other thing you should notice is JMS exception. JMS runtime exception. Okay, so in the new API, everything actually still throws an exception. Okay, however, it doesn't throw a JMS exception. It throws a JMS runtime exceptions, which means you can omit it if you so wish. Okay, if you omit it, what's going to happen? Well, this runtime exception is going to bubble up your execution stack and probably result in a 500 server 500 error. Okay, that you can then configure to say something useful, like an unexpected error occurred. Please, contact your administrator at this email and phone number, right? Which is at the end, what you would do anyway. However, if you really wanted to handle the exception, you still could. Okay, so you could catch a runtime exception and do whatever it is useful thing that you want to do. Okay, so both possibilities are possible. All right, moving a bit farther on this, how did we arrive at this? Okay, so rather, is this the right place to do that? Let me double check myself real quick. Yes, this is the right place to introduce this concept now. Okay, so remember I told you well, how do we get around the problem of how do we get around the problem of doing convention over configuration? Okay, namely making the common case easy while making the exotic, okay, very complex, elaborate case still possible in one single API. Okay. So the first thing is we couldn't do this. We tried very hard to do this using injection and scoping and just preserving the old APIs. So one of the ideas was to simply allow the injection of a pre-created message producer, the old message producer object. The problem with that approach is however we tried, it just wasn't backward compatible, and it wound up being a very, very complex API. So we had to make the decision of creating a new abstraction, and basically this JMS Context Object is an encapsulation of a connection, session producer, and a consumer. Okay, you still create it from the connection factory. Okay. But the big distinction here is to understand is that a actual provider may or may not actually create those physical connection, session, and producer and message consumer objects. It may choose not to do so. Okay, as an optimization step, it may create a flatter API, that's more efficient. Okay, if it so wishes. All right. So logically speaking, yes, it's an abstraction over those APIs, but not necessarily so. All right. However, this API is backward compatible because if you look in detail in JMS context, you can actually retrieve those older APIs from a JMS context. Okay. So you can say things like JMS context.get session. Okay, and that is necessary. Why? It's necessary if you are using the new API and the old API together. All right. The other difficulty that we needed to handle is that we could have created just one flat API. Okay, so it could have been just JMS context that does a whole bunch of unit operations. Send this message, receive this message, send to this topic, send to this queue, and so on. Okay, what is the problem with that? Can anyone guess what the drawback of doing that would have been? To create a completely flat API that has a bunch of command methods or utility methods, if you will. When will that fall down? Come on, anyone want to take a guess? This is an easy one to guess. I gave you plenty of hints throughout the presentation. Okay, never mind. Let me tell you. So this will break down. Okay, when you're doing more than an atomic utility operation. Okay, so for example, if you are sending 10,000 messages in a single session, okay, that API is going to break down, because if it's a utility method, then you're implicitly probably opening and closing the session for each of those APIs. It gets even worse. Okay, so if you try to do a send and a receive. Okay, so if you've ever if you know about the request response, okay, style of doing JMS messaging, that would break down. Okay, because in that same session, you'll be doing a send and then a receive and then creating a temporary queue in the middle. Okay, so that wouldn't be possible if it was just a flat utility API that just does one thing. Okay, so in order to deal with this challenge, we had to introduce at least one level of intermediate objects. Okay, so those intermediate objects are JMS producer and JMS consumer, and they roughly correspond to the old message consumer and message producer APIs. All right, that's what they do. A JMS producer sends messages, a JMS consumer receives messages mostly in a synchronous fashion. All right. However, the reason we could get away with this is because we applied another design technique, okay, to reduce the burden of having to deal with intermediate objects, and I'll tell you what that design paradigm is in just a second. Okay, I already told you it's all runtime exceptions. Okay, so you do not need to deal with checked exceptions in the new API if you do not wish to. Okay, questions on any of that? Pardon?
That reason you gave for that, like when you create this utility methods, would it work if there are more messages, sent and received in the same second? Why do you say this?
Okay, so let's say we have a flat API, okay, that says send message and receive message. So that unit API is essentially going to be a stateless operation, do this thing. Right, but in reality, that send and receive and creation of an intermediate queue, right, to get that sent message back. So the way in request response works is, here's how you send a message. Okay, before you send that message, you create a temporary queue for that session. All right, you pass in the reference to the reply queue in the message that you're sending. The receiver, will process that message and will send you back a message on that temporary queue that you created for that session, right? And on your receive side, you will listen and you will do a blocking receive call, okay, to receive a response back on that queue, okay? So it's not one atomic operation, but rather 3 operations in a single session, right? So that is why if you try to design that in a stateless API, it simply wouldn't work. You would need a handle to the session somehow, right? And you'd have to somehow demarcate boundaries to say, hey, these 3 operations are actually interrelated, okay? You need to do them in this sequence, and it should be following this particular session, right? Same thing with, let's say you are sending 1,000 messages, okay, but you're sending messages 10 per session, okay. So again, you would need some kind of API to manage that workflow, okay, to say these operations belong to this session, these operations belong to this session, and the like. And you could go on and on. There's a lot of other use cases where you could construct where you need some sense of workflow, okay, of a state machine rather than a stateless machine. A utility API, okay, will not do that because it is designed to be stateless, okay, in effect. I don't want to point anybody out, but let's say Spring JMS template, okay. If you try to do something like this in Spring JMS template, the only way you can accomplish it is by actually using an escape hatch that goes down back to the old JMS API using the callback mechanism that's built into Spring JMS template. That's why it's there, okay, is because when you deal with situations outside the common, well, a flat API will not serve your purpose. You need something that is going to go into callbacks, and callbacks is the mechanism they use to sort of get around that problem of trying to bind together a session for multiple objects. And even then, you can't really elegantly do that. Even there are cases where even that will break down. Okay, so that is why you need some kind of intermediate host, right, to say this is a representation of the common session, and whatever we do in that session is interrelated. Okay, so the commonality in this case is the JMS Context API, and the unique things that you're doing within that session is the message producer. Okay, message producer and message consumer. Okay, so messages are sent by creating a JMS producer object. Okay, again, I talked to you a bit about that. So now let's get back to, well, how do we accomplish this? Okay, so how do we accomplish interrelation of operations? Okay, so luckily, all right, what are we talking about in the end? I mentioned the word workflow, I mentioned the word state machine. In reality, what we are doing is creating algorithms or scripts, okay? Things that interrelated things that we do in a certain sequence or order, okay, or iteration. So luckily, we do have actually a design paradigm to handle just that case. It is called the builder pattern or a fluent API. Okay, so using the builder pattern or a fluent API, what you in fact do is in a programmatic fashion describe a script, describe a scenario, describe a workflow of what it is that you are trying to do. Okay. All right. So in fact, that is how we did it, and you'll see that in action as I explained to you the distinction between the old API and the new API. Okay. So here's a very simplistic example. In this case, this is a JMS 1.1 API. I'm doing a message send to a destination. Okay. However, in order to do that, I'm actually setting a few quality of service parameters at the producer level in this case. All right. So I'm telling the producer the delivery mode for this for this message. In this case, just one message. Is supposed to be non-persistent. The priority should be 1, and the set time to live should be 1,000. Okay, so these are the quality of service parameters for this message. Okay, but there could be multiple messages here that share exactly those qualities of service, or perhaps some other set of messages in that session that do not share those quality of service parameters. Okay, so in the old API, the API looks like this, right? It has to be a bunch of flat calls, okay, individual calls. And why is this? This code here actually follows a design paradigm as well, one of the original design paradigms in Java. Anyone remember it? Pardon? I don't know the name of it, but I've seen it all over the place. But what is it? What is it called? Anybody from the late 90s at all? Okay, okay. Java beans. Okay, Java beans, namely properties, getters and setters. Okay, so that is the design paradigm here. And these are message producer is a Java bean. Okay, and hence it has a bunch of properties, and that's really what you're doing here. You're setting a bunch of properties on the message producer via individual setter calls, and then you're invoking some action. Okay, so you're changing the state using the setters and invoking a business operation. Okay, that's the design paradigm. The problem with this design paradigm is that it's relatively verbose and impossible to compose. Okay, you cannot compose a script this way. It's basically not a functional style of programming. It's an imperative style of programming. All right. So what do we do in order to make this functional? Well, it's actually very simple. You apply the builder pattern. Okay, if you apply the builder pattern, you can in fact make it composable and make it more script-like. Okay, so the translation from this to this is going to be context.create producer. Okay, in that same line, okay, you are setting your script. Okay, so you're saying set delivery mode, set priority, set time to live, and then do the send. Okay, in one fluent line, right? So it is functional. If you read this bit of code, it is close to the intent of what you intend to do. Okay, it is also composable. Okay, so you could break off this composition here. Okay, and then you will have a handle to a JMS context. Okay, a JMS producer that has these quality of service features, and then you could send out 10 messages. Okay. To potentially different destinations using those exact same quality of service. You could go even further. You could say, well, I have 10 messages that use delivery mode non-persistent and priority 1 and set time to live 1,000. But there's another set that uses a set time to live 10. Okay, so you can still do that using the builder API by creating a message consumer build, okay, here. All right, and then for this first set of messages, you'll set time to live 1,000 and you'll iterate over that. Okay, and then for the other one, you'll take the previous set that you've created, and then you'll call set time to live again. Okay, instead of calling this entire line, and call a send of those messages in another set of iterations. Okay, so it's a very, very powerful design technique and sort of an obvious one. Okay, it was out there for us to just use. Okay, in this particular case. Okay, now okay, so one little thing that we should note here is that notice that we also didn't create the message object. Okay, there is no message here per se, but I'll get to that in more in a second. Okay, so we set in the previous example we set values at the producer level, right? In this example, I am actually sending. I'm actually setting state at the message level instead. Okay, so I'm saying for this message I want the property to be foo and bar. Okay, and again that's the old imperative style Java Bean style API. All right, if in a builder pattern it becomes like that. All right, so you still do not need to create a intermediate message object. Okay, so you're just sending the message payload, which is hello. All right, there is no need to create a JMS message object per se. You can still use a Fluent API to do that, and in fact you can mix and match these guys. All right, so you could set message level properties as well as producer level properties as well as connection level properties, all using the same builder API paradigm. All right, so you could say here all of this plus dot set property foo bar dot send destination message. all right, and vice versa. All right. Okay. So I gave away the other big sort of trick, which is in the wild, what we observe most of the time is that people are just sending a simple message. Okay, send this message, and they're not really using message headers or message properties. Okay, what they're interested in doing is simply sending the message payload. So in that particular case, it's a design. Again, it's an imperative style imposed upon you. If you're needing to create a JMS message object every single time, okay, even if you're not using anything else other than simply the payload. So in order to reduce this, it's very simple. What we can do is on the JMS producer object, okay, we can simply have overloaded versions of the send method that takes the various corresponding payload types, okay, that correspond to the existing message types as parameters. Okay, so you could just do a send call on a string or a serializable Java object corresponding to an object message, corresponding to a string message, an array of bytes representing a bytes message, and a map object corresponding to properties message. Okay, and note that these actually are in the old API as well. Okay, so we've added these methods not just to JMS context, but also to the older message producer object as well. Okay, so you could use this without having to even use the JMS producer in your old code. Okay, and allow for gradual refactoring. But you are still able to send the JMS message object if you so wish. There are cases where you may find it advantageous to do so. The most obvious case is, you have some old bit of code that's creating a JMS message object, and you're using the JMS context, newer JMS Context API. Well, there's still a bridge because the new API still recognizes the JMS message object. Okay, and its subtypes. Consumer is the same thing. All right, so basically this is an intermediate object mostly hidden away in the bowels of a builder API. Okay, they essentially consume messages, and same sort of design paradigms applied here. It's using the Fluent API. It's geared towards the common use case. Now, the big common use case actually that we wanted to change here is that when you create a message consumer today, and you create a connection, okay, create a connection and then create a session and then create a message consumer, that message consumer is actually not started by default. Okay, so this actually trips a whole bunch of people up. They call message producer.receive and then nothing happens. Okay, well, why doesn't anything happen? Well, you won't. In order to start receiving messages, you need to call connection.start, and connections in the old API are by default stopped. Okay, that's what their initial state is. All right. In this particular case, though, it's the opposite. Right. So now, when you create a JMS consumer, it will be automatically, the underlying connection will be automatically started for you. Okay. However, this need not be the case. Okay, there may be cases where you want to wait, okay, for some event before you start listening on the message producer. That is also possible. You simply there's a configurable property to say set auto start false. Okay, on the JMS context, and that way you can then explicitly control when you want to actually start the connection. Okay, so that is also available. All right. Same thing on the receive side. Okay, so again, you do not need to necessarily receive the entire JMS context, entire JMS message. Okay, if you're not using things like headers or properties, you can just receive the actual payload, and the way you do that is like this. Okay, so let's say you're receiving payload of string. All right, well, you don't need to actually get a handle to the intermediate JMS message object. You can simply say, I want to receive a string class or a serializable class or a byte, okay, and the like, and it'll just translate that for you. The return type will be of the type that you specify. Okay, Mm-hmm.
But it looks like you can specify a payload type, and it'll only get messages that match that payload type. Or try to
It will not. No. So this is basically if that is happening, you will need to retrieve the JMS message object and check its actual type. Okay. So this is simply assuming that you know what you're doing.
assuming that I know the message that's coming in is going to be a string.
Right.
It'll work. If I pass some other object that doesn't cast a string claim, the object comes to the ground.
Yep. You'll get a class cast exception more than likely. Yep. Yep. Okay. All right. So okay. So we're here. Okay. So pretty close to the functional core. However, there's still a little bit of mechanics here, right? So the biggest mechanical piece that still remains is this sort of artificial try with the resources block and as well as the step of creating the JMS context from the connection factory. But other than that, we've managed to basically eliminate a majority of the empirical code and pretty close to the functional core. Okay, so can we do better? And the answer is yes, we can. Okay, and how do you do that? You do that via injection and scoping management. All right, so what you can do here is inject the JMS context object where you're going to use it in the class that you're going to use it, and then simply use that injected instance. Okay, so that injected instance hides away the connection factory details whatsoever. Okay, so that is all transparent to you. In fact, our design goal was to make the connection factory object completely vanish. Okay, so hopefully going forward, you don't need to even know that there is such a thing as a connection factory, and I'll explain to you why that is. All right, in this particular case, actually, if you look at this code, the only reference to a connection factory is the fact that I'm explicitly specifying one via annotation. Okay, at the injection point. Other than that, there is no reference to a connection factory. Okay, it's just the JMS context message object. All right. Okay, so how are we doing this? Before we do that, I want to explain a bit of the semantics of this injection. If you wanted to, you actually do not need to specify a JMS. You actually do not need to specify a JMS connection factory anymore. Okay, so you can, in hopefully a majority of the cases, simply do this: inject JMS context object, and that's it. Okay, why that is, I'll explain to you in just a second when we talk about Java EE platform alignment. But I'll give away the trick now. If we don't specify anything, we basically default to a platform default connection factory that is supposed to be reusable in a majority of cases. Okay. If you wanted to do that, of course you can. You can specify a JMS connection factory. You can specify JMS session mode. You can specify password credentials. All of the things that you would typically specify at the connection level or the session level, you can still do that. It's just moved from an API to a declarative style of via annotations. Yes, sir.
Were there changes that the different implementers, the implementing vendors, IBM, etc., had to make to be compliant with JMS 2.0? Because it's still a connection factory. They're providing us the root of everything.
Yes, there is a connection factory, but the thing is that basically designing this API allows for the possibility of optimizations. Okay, so you don't necessarily know if it's a connection factory or not. If you just did a default injection like this, okay, if there's some other optimal way of handling that, the provider is free to do so. Right.
Setup-wise, the underlying JD object that I'm getting from the EE server is still going to be probably called a connection factory.
Right.
Well, its implementation may be very different.
In fact, there may not be one, right? It may not even be retrieved from JNDI for all you know, because it may be bound to the CDI subsystem instead, like this. It's really all up to the implementation provider. But the most conservative interpretation is yes, there's an underlying JMS connection factory, and it's the default, and that's where you're creating the JMS context from. And this applies to the entire API. So, for example, a provider can choose to omit ever using a intermediate JMS message object, okay, for their API. If it doesn't make sense, if they can write it in a more optimal way, they could just eliminate that step altogether. Okay. All right. Okay, moving forward. Okay, so how is this working? So let's go back to this, go back to that injection code. All right. Where is the close here? Can anyone guess when is the underlying connection that represents that that line of code, what you're trying to accomplish? When can you take a guess of when it's opened and closed?
Send.
Pardon?
Send method.
It's a decent guess, but not the best guess. If we did that, then we would basically be doing the equivalent of a flat utility API. Right? If we did open and close every single time we're performing an operation, right? You wouldn't be able to write more elaborate scripts. Okay, so if there was 10 message sends here, then if we did that, then you would be calling open and close 10 times. So that's not quite right. Anyone else want to take a guess? Pardon? Yes, it's exactly. It's bound by default. It is bound to the transaction boundaries. Okay, so let's think about that. What is the value of transactions? A transaction is a unit of work. Okay, so that is a logical place to tie in a logical session. All right. So what is happening here is that actually this you can imagine this to be an EJB, which means this method is probably transactional. It's bound, declaratively bound to a transaction boundaries. Okay, a transaction is begun here and committed here. And what actually will happen, for example, in JMS, is that the first time you call create producer and send is when the actual session is going to be opened. Okay, so that is opened lazily. Okay, within the scope of a transaction, it will detect that the transaction exists and attach the session that it opened to that transaction. Okay, and all of those resources are going to be closed out when the transaction commits, which roughly corresponds to the boundaries of the method. All right? Right, so that is how that is happening using dependency injection under the hood. We're doing this using dependency injection scoping. Right? We can detect the scope of a transaction because it's a managed object. It's not really a POJO. Right? There's a bit more intelligence in the runtime for it. Okay, so. Somebody asked me a question before I show you the answer. What's the problem with that approach? If it was just the transaction manager, what would be the problem? If we said that the lifecycle is bound only to the transaction manager, what would be the problem?
If you want to have multiple transactions within a particular method in the class.
That's still handled because you can do a manual commit, JTA transaction begin and commit, and you'd still be within the scope of the transaction, not quite. What's the other big problem? Okay, what happens if there's no transaction? Okay, all right, what happens if there's no transaction? Well, the answer is if there is no transaction, then we fall back to what's called the request scope. Okay, in Java this means something very specific, but in layman's terms, basically you can think of it as your method call boundaries, or more specifically, your thread boundaries. Okay, so essentially the JMS Context Object will be automatically destroyed for you when the thread context ends. Okay, usually it's just in a world of web, it's just one HTTP request. When this HTTP request ends, you're done. Okay, we clean up the underlying JMS Context Objects. Okay, there's a bit more nuances to that, but I won't go over it. I don't think there's really a reason to do so. Okay, I'll talk a bit about the new features, and again, there wasn't a whole lot that we could really look at. One of them ones we added was delivery delays. Okay, so what is this? In many cases, or in some cases in enterprise messaging systems, the common case that we see is people are sending a JMS message to trigger something. Okay, and in all reality, they do a message send, and then they use some kind of scheduling mechanism to read that message at a given period in time. Let's say the end of the day, okay, and that's what when they do something with this message, okay. So in order to facilitate, to make this easier, you can actually do this at the client level, at the send phase, okay. So what we have now is basically a method in both the old API and the new API called set delivery delay, okay, and it takes long as a parameter. And what you can say is, okay, send this message, but not right now, right? Send it after, you know, after such and such a time elapses, okay. Asynchronous send is another one of those, right? So if you're sending one message, it's not a big deal, right? Your latency to get an ACK from the message-oriented middleware is probably something in the order of seconds, okay? So that's not a big deal. But what if you're sending 10,000 messages, okay? Then you know, getting acknowledgement mode for 10,000 messages becomes a latency issue. Okay, so in order to get away from that, what you can do is you can now do an async send. Okay, so you do a send method, you do a send call, and again available in the old and the new API, and then you get a callback. Okay, so you get a callback that says, hey, tell me when this message was was acknowledged or not. Right, so this is basically removing that I/O latency. You can send a bunch of messages, go to something else instead of blocking that thread, and then get a callback later, okay, and act upon it later. Okay. These are new features. Yes.
So,
Yeah.
so we don't have a delay message earlier?
I don't think so. No, in fact, we didn't. No. Yeah. All right, Java EE alignment. A bit of this, and the biggest one, biggest two actually, is this first one, which is the default connection factory. Okay, so now every single Java EE runtime is required to have a default connection factory. Okay, so as a result, you never need to know about the connection factory. You can just simply omit that detail. There's another change that we made to go along with this. Okay, we required every single JMS provider to be able to work with other JMS providers. Okay, so let's think about this for just a second. This may not be an obvious statement unless you know JMS intimately. So let's say in your messaging system you have two message-oriented middlewares. Okay, let's say you're on WebLogic. You're using WebLogic MQ. But you also need to talk to WebSphere MQ. Okay, so you're doing that via registering a destination or a connection factory if you need to, or let's say just a destination in WebLogic for a WebSphere MQ destination. Okay, so what we've done is we've made it such that both of these providers, okay, are required to work with each other's connection factory. Okay, so what is the end result of this? The end result of this is WebLogic will have a default connection factory. Okay, you do not need to register a WebSphere MQ connection factory to work with a WebSphere MQ destination. Okay, you can just inject the same JMS Context Object and still just continue to work with WebSphere MQ. Okay, because WebSphere MQ is required to work with the connection factory that WebLogic is providing. Okay, now there is one case where you wouldn't want to do that. Okay, so when you do this, you will lose the ability to do provider-specific optimizations. Okay, so when the connection factory and the destination are the same, the underlying provider could take advantage of that fact and do runtime optimizations. Okay, so there is a valid case for still having a connection factory specific to WebSphere that you use, in the WebSphere cases, right? Okay. Okay, so next one is these two annotations: JMS destination definition and JMS connection factory definition. Okay, this is goes hand in hand with an annotation set that we introduced in Java EE6. The big one is data source definition. So prior to Java EE6, the way you defined data sources, the only way you could define data sources is some mechanism other than the standard. Okay, so it's either you go into the admin console to create a data source, you have some vendor-specific XML deployment descriptors, or some server settings, okay, to create a data source. As of Java E6, you can do that via just an annotation, okay? And now with Java E7, you can do the same thing for JMS as well. Okay, so there's no need for you to create these resources at the server level. You can define them right with the application using an annotation like this, okay? And it will be auto-created for you during your application deployment. And there's also XML variants of this, okay? So basically, you have these two XML variants that you can put in your web XML or EJB jar XML or application XML, okay? And the idea is that if you have both, okay, one overrides the other. Well, what happens is the annotation, the XML version always overrides the XML version always overrides the annotation version, okay? So you can use it for scenarios where you want to vary the default deployment. Okay, so the default descriptor is in annotations, and then you can override it using XML if you so wish. Okay. Moving forward, some AMDB alignment. This is actually a fairly minor one, so I'll explain this. Again, because of that mismatch in terms of not updating the JMS API for a while, a lot of in MDBs today, when you use message-driven beans to listen to JMS messages, a lot of those activation configuration properties are actually non-standard. So they vary between app server to app server. Okay, even simple things like, hey, what JMS topic or queue am I listening on? Okay, even that part varies from, let's say, JBoss to WebLogic to Glassfish and whatnot. Okay. So we took this opportunity to actually take a majority of those activation configuration property values and standardize them. All right. So now you have standard values for a vast majority of them. So here are some examples. There's which keyword topic am I listening on? Which connection factory should I use for this MDB? If in case of a topic, this is my client ID and subscription name, so on and so forth. These are all standard now. Okay, so there will be still cases where there are some exotic connection property values that is not supported, but for the most part, we've I think done a good job of standardizing most. Okay, I have 5 minutes left, so I'm going to skip this over very quickly. So what is the current implementation state? Glassfish, Wildfly, Tmax of Juice support JMS 2.0. I have just heard that SwiftMQ also now supports JMS 2.0. WebLogic is on its way to implement JMS 2.0. JBoss AS is on its way to implement JMS 2.0 because they're implementing EE7. Okay, and Glassfish is the upstream project for WebLogic. Wildfly is the upstream project for JBoss AS. Okay, WebSphere is working on. In fact, if you look at WebSphere Liberty beta, a few months ago, they already have support for JMS 2.0. Okay, the rest of them TBD. Okay, they're in various state of adopting Java E7 at this stage. Okay, I want to talk to you a bit about JMS 2.1. Okay, the initiative for JMS 2.1 has already started. Okay, and these are the kind of things that we are looking at. You can take a look at this later. I don't have a terrible amount of time to dig into each of them. I'll just show you actually the one that is most important, and that is declarative JMS listeners. Okay, and the way I'm going to do this is quite deliberate. I'm going to show you a Jira entry on the JMS spec. Okay, that you can, if you wish, you can do the same thing. You can create a Jira entry. You can vote on Jira issues. You can comment on Jira issues if you so wish. And so these are the ones there that are there. By the way, if you want to get a handle to this presentation, you can do so. Okay, so just get on Google and Google the name of this presentation. It will take you to a SlideShare account. Okay, that has this slide deck on it, so you can take a look at the details there. So let's take a look at declarative JMS listeners, and actually both of these Jira entries are entered by me. There's other folks that you'll see commenting on it, but okay. Maybe I should have just copied and pasted this into a browser. Okay, I don't want to cancel this. I think it's going to mess things up. So just give it a few seconds and hopefully it will pull up soon. Okay, here we go. All right, so today you principally listen to JMS messages using MDBs. Okay, MDBs are pretty good. You know, they're pretty declarative, fairly compact. But the big problem with MDBs are twofold. One is that they use a very generic syntax. Okay, they deal principally with activation configuration properties. Number one. Number two is that there is a specialized component. Okay, so if you want to listen to JMS messages, it has to be an MDB and nothing else, right? So what we can do is we can do better. We can first and foremost create a more specialized syntax, okay, for JMS. Number two, decouple it from EJB altogether. So take a look at this example here. This is just my listener component. It is not an EJB. Okay. You could envision that it is application scoped, or in this case, I have an example of a pooled scope. Okay, but now what you can do is, instead of having just one on-message method, you can have multiple methods anywhere. Okay, in your POJO, listening to a JMS message. All right. So in this case, I have a example of listen, and it takes the JMS message as an argument. And you can just have one annotation that says, "Hey, JMS listener," and gives you all of the parameter, all of the things that you want to specify via activation configuration properties in a far more compact fashion. So destination name, client ID, subscription name, any message selectors that you may need to apply, and so on. The other power of this is that you can actually unwrap the underlying message body. Okay, you do not have to necessarily deal with the JMS message object anymore, because you could the runtime could give you just the direct payload that you need. Okay, some other examples, you could inject message properties and JMS headers this way as well. Okay, so you don't have to deal with an API way of doing things. You could just use injection to do all of these things again. Even more powerfully, once you get into this mode of thinking, you can apply other services, such as in this case, I am, for example, providing a service of batch delivery. Okay, so you can say, I don't just want one message, I want an array of messages. Okay, so I want my batch size to be so and so. I want some retries associated with that. I want a retry delay. And so on. So it becomes a much more sort of powerful DSL, okay, as compared to just message-driven beans. And the rest of this is just discussion. I am going to try to see if I can show you the other one. Pardon?
Said copy and paste.
Oh, shoot. Okay, so what I've tried to do here is say, we could codify common design paradigms. So this one I showed you before already. So this is just taking handling a batch of messages as opposed to one message at a time on the listener end. So just really a copy paste of the previous example, but we could do much more than this. Okay, so for example, you can do ordering. Okay, so for example, you could take a batch of messages and order them by timestamp, or priority, or some other sensible metadata. Okay, if you begin to do that, you could, for example, set up DL queues. Okay, so if a message fails, using this declarative style, you could specify a dead letter queue. So if message delivery fails, please put it in this particular dead letter queue. Okay, so you could do that. Similarly, you could specify timeout. All right, for and a retry limit as well. You could do things like, for example, request reply pattern. Okay, the pattern that I talked to you before on the receive side. Right. So what you can do here is have a destination lookup. Okay, who am I listening on? Right. You'll receive the unwrapped string request. you'll process this and send a response back, okay? And what we can do here is basically detect the reply to queue, okay, under the hood and send this string message back to your reply to queue, okay, all declaratively without you having to do anything else other than simply specify this at the POJO level. So there's a lot of very interesting possibilities that we can take a look at for JMS 2.1. Okay, so and you should be involved and in telling us and working with us if you have other ideas or what you think of these ideas in particular. Okay. I'm going to skip over the summary. I'm over time already, and I'm going to tell you these resources. The main resources that I want you to be aware of is that the Java EE 7 tutorial has been updated with JMS 2.0. Okay, it is a decent section on JMS 2.0, and also you have a self-directed hands-on lab. Okay, if you want to start hacking some JMS 2.0 code, it's available at that GitHub URL. Okay, you can go ahead and start hacking some JMS 2.0 code yourself. Other than that, URL for the JMS spec, URL for Glassfish, URL for OpenMQ, which is a reference implementation for JMS. And I also always like to point out the Aquarium blog. Okay, if you want to stay up to date with JMS 2.1 or generally Java EE, that's one of the best blogs out there in my opinion to do so. And also you could follow us on Glassfish. Okay, so we mirror the contents of this blog and more in our Glassfish Twitter handle as well. So if you can feel free to take a look at that. Okay, so I'll give you just a second to sort of copy that. These are on my SlideShare, yes, SlideShare deck, correct. Okay, so that is all I have. Thank you very much. I really appreciate it. I hope this makes you interested in JMS 2.0 and hopefully in JMS 2.1 as well. Thank you very much. Have a good evening.